Okay, so I need you to go to slide number 25. And I want to do a little bit of review with the electron configuration, and then I'm going to talk about ions and isotopes. So you have an in-class assignment and you will have a homework assignment that you need to work on. Okay, so here is a orbital diagram, and what it does is it helps us give an electron configuration for a specific atom. And please remember that two electrons fill each orbital. And because electrons are negative, p and d orbitals have electrons fill each empty orbital first. Before pairing up. And I will practice that in a little bit here. All right, so the first one I want to do with you is lithium. And lithium has an atomic number of 3. Notice it's not 6.94. So I'm going to write lithium, and I'm going to put the atomic number at the bottom there. So that means I have 3 electrons, and I'm going to use an arrow to represent an electron. Now, I said that 2 electrons fill each orbital, so I'm going to put 2 arrows in here, and I'm going to represent a down arrow as them pairing up with each other. Okay, so right now I have 2 electrons, and notice that they're filling in the lower energy level first before I add a 3rd arrow, which is in the 2nd energy level. So I'm going to write the electron configuration. And what does this mean? This is the address for these electrons. So right now, they are in the 1s orbital and the 2s orbital, and there's a total of 2 in the 1st energy level, and there is a total of 1 in the 2nd energy level, and together they equal 3 electrons. Now I want to show you how they fill the p orbital, and in order to do that I need a bigger atom, and I'm going to use oxygen. Notice it has an atomic number of 8, which is not 15.999. So I'm going to get rid of this one here and start over. So I have oxygen, which has an atomic number of 8. That means it has 8 electrons. And once again, I'm going to fill it in order of increasing energy. And the 1st energy level, I have 2 electrons. The 2nd energy level, I have 2 electrons. Now notice I filled all of those orbitals, and I need to fill up the next energy level, which is 2p. And right now I used 4, so I have 4 more. And this is how they fill their orbitals. So p orbitals, the electrons are going to fill each empty orbital first because they want to spread out and not repel each other. And once they fill each empty orbital, then they pair up. So that 4th electron goes into the 1st orbital that it filled, and it'll pair it up. Now, when we write the address, it'll be 1s2, 2s2, and then 2p. I have 4 electrons in there, so I'm going to write 2p4. And, oops, sorry. Ugh. Okay, I have 2 plus 2 plus 4 gives me a total of 8. Now, if you were to look at the oxygen at the top there, The electron configuration is helium in brackets 2s2 2p4. So what is this? This is what we call noble gas notation. So what we do is we use noble gases to kind of give us a shortcut for writing electron configurations. And what that means is the helium in brackets is also equivalent to 1s2. So when I write this, I'm going to put helium in brackets and then 2s2 2p4. So when I do that, that means helium is represented by the 1s2 electrons, and this is just another way to write the electron configuration. Now, you would probably argue this is not going to save a whole lot of time, which I kind of agree with you, but when you have bigger atoms, the noble gases cut out a lot of the address that you have to rewrite, and it'll make more sense when you do bigger ones. Okay, so now I'm going to move into isotopes. Oops, here we go. Oh. Now, a lot of you struggled on the last quiz because you forgot where the atomic number is. And notice it's in the bottom left of the element symbol. So they share the same atomic number, but when you look at their mass number, they have different numbers of neutrons, okay? And that's the upper left number. So the mass number is protons plus neutrons, okay? Whereas the atomic number is only protons. And in this problem, they wanted to know how many neutrons are in the isotope. So please remember, it is mass number minus atomic number. So when I'm solving for neutrons, I want to take the bigger number, which is mass number, and I want to subtract the smaller number, which is atomic number. And when I do that, I get 34 neutrons. All right, so I have a couple more here where they're looking at neutrons. And notice that they give me the mass number. I don't know what the atomic number is. So I have to go to the periodic table. And if you want, you could type in chlorine. And they say I have 17 for my atomic number. And neutrons is going to be 37, which is mass number minus atomic number. Always bigger minus smaller. And that gives me 20 neutrons. Now for carbon, I have to look at its atomic number. And when I look at carbon, its atomic number is 6. So for number of neutrons, I want to do the bigger number, which is 14, minus 6, which gives me a total of 8. Okay, last section here, and then I'll show you a couple practice problems. So notice that now we're talking about unequal numbers of protons and electrons, okay? And ions are not neutral. They have a charge. And notice that if you have a positive ion, it loses an electron, and it is losing negative charge. That is why it becomes positive. So electrons are negative. So if you have a positive ion, it loses electrons. When you have a negative ion, it is gaining negative charge. So it's gaining electrons. And I'm going to practice that with you here. So I need you to go to Canvas. And I shared with you an assignment. Sorry, I don't have it in my homepage yet. It will be on your homepage when you come to class. Where'd it go? Sorry, guys. Oh, here it is. Okay, so ion isotope review. This will be on your home page. So I need you to put this into Notability. And I'm going to show you just 2 problems, and then you're going to do the rest yourself. Okay, you cannot do this without a periodic table. So you need a periodic table. And I'm going to do aluminum. So what I need to do is I need to find aluminum on the periodic table. And when I do, it has an atomic number of 13. Oops. Okay, so atomic number 13. Now, because it has a +3 charge, it lost 3 electrons. So now it has a total of 10. So the correct answer for this would be B. Oh, and I'm assuming you guys can look at your notes to answer the question number 1, which is, what is an ion? Okay, I'm going to show you how to solve this for chlorine. So notice that chlorine, if I go to the periodic table, has an atomic number of 17. So when I'm looking at the number of protons, I'm going to write 17. Now, because it has a negative charge, I'm going to add an electron because it's a -1. So it has a total of 18 electrons now. Okay, so please remember to use your notes and your periodic table, and you have a classwork assignment.